Okay, so yesterday we did side, 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 and side, angle, side. Okay, today we're going to do angle, side, angle, and angle, angle, side. Okay, and I'm going to go through a couple more examples of the two-column proofs also. Okay, so put this in your notes for section 4.5 on proving triangles congruent. Okay. First, there's a couple of postulates, or postulate in the theorem. Postulate 4.3. Okay. It says if two angles and the included side, two angles and the included side, and if you look, you can tell it up here. There's two angles and there's a side in between. If two angles and the included side of one triangle are congruent to two angles and the included side, that means that side has to be between those given angles of another triangle. Right? If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Okay, and label that. That's angle, side, angle. So don't use the postulate 4.3. Instead, say angle, side, angle when you're doing your proofs. Okay. Now draw a picture. Draw a triangle, and then try to duplicate it as best you can. Okay. And label it. Okay. Label this angle is congruent to this angle. And when you're looking at your iPads, those marks are pretty small. So remember, you can enlarge your pictures to see those. Okay, and label this angle is congruent to this angle. And then it has to be the included side. So it's got to be this one congruent to this one. Okay, and that's going to be the angle, side, angle. So now you've got side, 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 angle, side, and angle, side, angle. Okay. Okay, now this one is a theorem. So theorem 4.5. Okay. It says if two angles and a non-included side if two angles and a non-included side of one triangle are congruent to the corresponding two angles and side. If two angles and a non-included side of one triangle are congruent to the corresponding two angles and side of the second triangle, then the two triangles are congruent. Okay. And that is angle, angle, side. Since it's not in between That's the non-included part. That side is not in between, so it's not included. Okay, okay, now another picture. Okay, and the label. Say this angle is congruent to this angle, and let's say this angle is congruent to this one. Okay, it could be this one congruent to this side, or this side congruent to this one. It cannot be this one, okay, because that one's included between the two angles. So I'm going to make it this one congruent to this one, okay, and that's angle side. So now we have 4, and that's the hard part when when I'm teaching a geometry class, it's okay because I know where we're at in the book. But when somebody comes in, if I'm not teaching geometry that year, and somebody comes in and says, "Will you help me with this proof?" and I have to say, "Okay, what have you had so far?" And if they can't tell me what they've had so far, then it's like, okay, then I got to look in the book and backtrack through that chapter and say, what postulates or theorems have you had? So up to this point, you have had side, side, side. So when you're getting ready for these proofs, you're trying to look for either 3 sides congruent, side angle side, 2 sides and an included angle, 2 angles and an included side, or 2 angles and a non-included side. So you may want to highlight that or underline it. That's what you've had so far, okay, for proving triangles congruent. Okay. Okay. Now I want to go through a couple of proofs as examples. Okay. They will say write a 2-column proof. The author goes through what they call flow proofs and paragraph proofs. We're not going to worry about those. We're going to write 2-column proofs, and it's basically, remember, statement and reason. Okay, first example. Say you're given L is the midpoint of segment WE. Make sure you put the bar above it, and WR, that segment is parallel to segment ED. Okay, what they want you to prove: triangle WRL is congruent to triangle EDL. Triangle WRL is congruent to EDL. When you're doing these on your paper, to me it's critical that you draw the picture on the paper. Don't mark it up in the, well, it's hard for you guys to mark it up on the iPad. Okay, draw it on the paper so you can try to mark the angles congruent, mark the sides congruent. Okay, so here's the picture. Draw one segment congruent to another segment like that. Or actually parallel. Sorry, parallel. Okay, and then connect these. Okay. Label this as W. Label this as R. Where it intersects is L. Label this as E. And this is D. Okay, now we've got 2 that are parallel. Remember, we marked those WR. We marked those with the little red arrows. And ED. Okay. And they tell you L is the midpoint of WE. Okay, so now start the proof. Okay. Okay, and I said yesterday, it doesn't matter if you split those givens up into two statements or one, it doesn't matter to me. This one, the author put them together. So L is the midpoint.
Bruce, can we use up 2 lines and then go right use up
Sure.
2 lines right down?
Sure. Sure. Say L is the midpoint of WE. And WR is parallel to ED. Okay, and I'm going to say that's given. Okay, if L is the midpoint, okay, and I'm trying to get triangle WRL, look at your picture, I'm trying to get WRL is congruent to EDL. Now, we won't always think alike, okay, and I might even work the proof. I might have worked it one way yesterday and one way today. There's not just one way, okay. So on this one, I ended up, the next statement, I ended up saying WL is congruent to LE. Okay, so WL, because L is the midpoint of WE. It's the midpoint of this one. Okay, so that makes this WL congruent to LE. Now, what's the reason? You could go definition of midpoint, or the author was actually using midpoint theorem. I probably would not count it wrong if you use definition of midpoint. Okay. And that goes back, those of you that were gone yesterday, that's back on page 129. Okay. Okay, then if you look, we've got 2, and we're trying to get triangle WRL congruent to EDL, and we've got parallel lines. Parallel lines. You don't know that L. You don't know that L is the midpoint of RD. But we can get angles. We got some angles. Yep. I'm going to do angle RWL. This angle right here, RWL, is congruent to which one? Go the other way. Yep, you've got to go in the right order. Okay, it's congruent to D, E, whoops, angle. You need the angle symbol there. Angle D, E, L. Okay, so now we've got part of it. And why is that true? What kind of angles are those? 2 parallel lines cut by a transversal. What kind of angles are those? Alternate interior. Okay, so alternate interior angles. And that's actually a theorem. No. I'm just trying to be more specific for your notes. Right? Okay, second one. I'm looking at angle WLR. Okay, so look at this angle, WLR. Which angle is that congruent to? Yep. Why? What kind of angles are those? Vertical. So those are congruent to E, angle ELD. Vertical angles. And that's actually a theorem also. Okay. Okay. Now, if you look, do we have enough? We've got angle, side, angle. So now, it's critical that when you do this, that you write it, they're asking us to prove it in that order. So that's how you need to write it. So triangle WRL is congruent to triangle EDL, and the reason is angle, side, angle. Okay. An angle side angle was actually, that was actually a postulate, right? Okay. Not too bad. Okay, that's the first example. Okay, let's look at another one. Is that enough time? Okay. Okay, another example. Same thing, write a two-column proof. Okay, you're given, okay, angle NKL is congruent to angle NJM. Angle NKL is congruent to angle NJM. Okay, you're also given KL, segment KL is congruent to segment JM. Okay, they want you to prove LN, that segment, is congruent to MN. Okay, now here's the picture. Start with kind of a V. Okay. Okay. Label this as J. This is point L. This is N. This is M. And this is K. Okay, now what they already give us? Angle N, K, L. This angle is congruent to N, J, M. This angle. Those are congruent. Mark them that way. KL is congruent to JM. Okay? If you want to, you could, and for some people, it's going to be better to do this. Okay? You know, if you need to, split that up. Okay, this angle is congruent to this one. Okay, and then KL, this one is congruent to JM, this one. Okay? I don't care if you can figure that's that whole thing. You can keep the picture together or you can separate it. Okay? Okay, now we start the proof. Two columns, statement and reason. Okay, so write down the given. Angle NKL is congruent to angle NJM. And segment KL is congruent to JM. And that's segment, and that's given. Now, to be able to get, notice it's not saying prove the triangle's congruent, it's saying proven parts. We're trying to prove LN, this is congruent to this. The only way you can get to parts congruent is to prove the triangle's congruent. Then you can go to corresponding parts of congruent triangles. Okay, so step 2. Okay, now you can write this out in 3 letters, or you can write it out in 1. In these 2 triangles, this angle is in both of them, right? You can either mark it here, or you mark it there. So angle N is congruent to angle N. I could have also labeled that angle JNK is congruent to angle JNK. Okay. Why are those angles congruent to each other? That's reflexive. Yep. That's the reflexive and abbreviated property of congruence. Okay. Okay. Now, do we have enough right there to prove those triangles are congruent? Yes, because we've got two angles and a non-included side. Okay, so we've got enough to say they're congruent. So triangle, now, you want to make sure you write it in the right order. JNM is congruent. If I start with J on the first triangle, J is congruent to which angle? K. N is congruent to which angle? N. And M is congruent to L. So I don't care how you start the J, N, M. You could start with N, M, J. You could start with M, J, N. But whatever you start with here, you've got to make sure it corresponds over on the other one. It's got to be in the right order. Okay, the order makes a difference. Okay, and what reason? Angle side. Okay, and that one was actually a theorem, right? That was two angles and a non-included side, because this side is not included. Okay. Okay. Now, as soon as you get the triangles congruent, their parts are congruent. Okay. So, and that's what we wanted up here. So, LN. And if you look at the order here, look at LN is congruent to MN. Okay? That segment is congruent to MN. Yep. Corresponding parts of congruent triangles are congruent. Okay? And that's all you need. Okay? So only took 4 steps, and one of them was given, so it only took 3 steps. If it helps you to separate your pictures out, then draw it both ways, okay, if that helps. Okay? Okay.